These two formulas are the same, except the k is a constant, and the constant typically is a tiny little number. And you're not going to round the constant. When you get it on your calculator, you're going to leave the whole number in your calculator and use the whole number, okay? Some of these are so small, they give it to you in scientific notation. Does everybody know how to read a scientific notation number?
I believe so.
Okay, so you would have negative 4.3 times 10 to the negative 4. You can put that in your calculator as negative 4.3 times 10 to the negative 4. And that times is going to be a e, but that has nothing to do with the e we're talking about. It's just the exponent of negative 4, okay? So you can key it in like that, or you can move the decimal places 4 places to the left and key it in as negative 0.00043. Everybody see that?
Yeah.
So that's just a little review of scientific notation. These numbers are going to be tiny. The rate is usually a bigger number. It's usually like 8% or 3% or 2%, but these numbers are going to be small numbers, okay? So, half-life. Does everybody know what half-life is? So half-life, in the 80s, when I was just a baby, I was in my early 20s, nuclear power plant in Chernobyl. There's a Netflix series on it.
Yeah.
I highly recommend it. There was a major meltdown, the biggest meltdown in nuclear power history. And that town was, everybody had to move away. A lot of people got cancer. A lot of people died of radiation exposure from the meltdown. And it is said that people can't move back there for thousands of years or hundreds of years. And that's because radiation has a half-life, and some radiation's half-life is like 24,000 years, which means if in my hand I have a pound of radiation, which I would not, in 24,000 years I'd have a half a pound. 24 more thousand years I'd have a quarter of a pound. It would keep cutting in half every half-life cycle. Like if I throw a piece of bread out in a ditch somewhere, it would deteriorate a lot quicker than what we're talking about. These are the radioactive compounds, okay? The half-life of CS-137, which is the name of the compound, is 30.2 years. So every 30.2 years, the baby is 1/2 the initial value. If the initial mass is one kilogram, how much will remain after 150 years?
0.5. Oh, I'm sorry. That was just half.
Okay. The first thing you do here is find K using the half-life, and then you answer the question. So I'm going to put a line here, and let's find K on the left, and here answer the question on the right, okay? If I have that A equals PE to the KT, and I know that the half-life is 30.2 years, that's my T. And E is a number. I'm looking for K, so I've got to put in an A and a P that would make sense for a half-life. In 32 years, if I start off with 2 grams of this stuff, I end up with 1 gram. You can use any number where the A is half of the P, any numbers. So if you put 10, then you end up with 5 in 30 years, 30.2 years. If you put 100, you end up with 50. It doesn't matter what you use, and unless you know, if you know that the beginning is always double the ending. Okay, so now I put in what I know. I know that this is 1 equals 2 times e to the k times 30.2, right? And if I divide both sides by 2, I get 1/2 equals e to the 30.2k. So I have to find k, and the k's in the exponent, so I'm going to have to use logarithms. ln base e of 1/2 equals 30.2K. Okay, we figure out the ln of 1/2. And then we divide that by 30.2. And you get this terribly ugly number, K equals negative 0.0229518,934. And now I leave that on my calculator, don't clear it. So now they want us to find out how much is left after 151 years. So I have the beginning we don't know the ending balance, but we know we start off with 1 kilogram times E to the 151 and then that K number, right? So what you're going to do in your calculator is put that in, but when it gets to the K in the exponent, you're going to hit second answer. So you don't have to rekey that number. You're probably going to have to rekey it. So if we put 1 times E to the 151 times second answer.
Where's E?
E is above the division sign.
Okay.
You should get that A equals 0.03125.